Okay, Mr. Watson here, and in this video we're going to be talking about types of muscle contraction. So I briefly mentioned concentric and eccentric contractions in the last video, but this video aims to explain the different types of muscular contraction that we have, and primarily we are concerned with three, but with the Cambridge syllabus we do need to know the fourth, so I will briefly mention that at the end, as the other three are more common. So, types of contraction. So we should have understood from the last video that the agonist provides the major force. Okay, so usually when we're talking about types of contraction, we are referring to the agonist, as the agonists are the main muscles that contract. Okay, and agonist muscle contractions can be divided into isometric, concentric, which is a type of isotonic contraction, eccentric, which is the other type of isotonic contraction, and isokinetic. So these type of contractions, we do refer to the agonist muscle, but I must mention that, for example, with the bicep curl, okay, flexion of the elbow, bicep curl, okay, even though the main agonist contraction on the upward phase would be concentric, we do have the rotator cuffs working in the background isometrically. So with the, as I mentioned in the last video, in the hip and shoulder movements, you're always going to have some isometric contractions working behind the scene to stabilize the agonist origin. But just to mention that. But anyway, here we go. So let's start with isometric. Okay, so this is just letting us know that muscles don't actually need to shorten or lengthen in otherwise to develop tension. Okay, so in isometric contraction, the muscle length remains the same. Okay, so as you can see in the diagram there, which is a planche hold, okay, the contraction of his triceps and the wrist muscles there to hold this position, they're contracting, but they are not changing length. The muscle length remains the same. Okay, so an isometric contraction usually refers to where the length remains the same. I mean, sometimes there is a little movement, but it's better to know it as the length remains the same rather than no movement. Okay, so this is where, for another example would be, if you were doing that bicep curl, as I often refer to, and I was to just say, hold. Once you start holding, and if I was to ask you to hold for 10 seconds, that then becomes an isometric contraction, no matter what the current position of the dumbbell is in, because you're now holding it. Okay? So another example, holding an object in front of you without moving it, so gripping a tennis racket, or we have the gymnastics ring hold, which we often see. Okay, so another statement we usually make here when we're referring to the force and the load, the muscular force precisely matches the load and no movement results. So the muscular length remains the same. Okay, so they are your isometric contractions. We'll now move on to the most common type of contraction, and these are our concentric contractions, and as I mentioned, the type of isotonic. Okay, not the drink. In concentric contraction, the muscle shortens as it contracts. So as you can see there, in the upwards phase of the bicep curl, the biceps brachii has shortened. It is the main agonist in that movement. So the contraction type of the biceps brachii is concentric. It has shortened. Okay. Now, the force generated is sufficient to overcome the resistance. So as you'll have seen on the last slide, I mentioned the force generated was matching, therefore we got no movement and no length change. Here, the force that our biceps brachii is generating with help from the brachialis and brachioradialis, okay, it's sufficient to overcome the weight of the dumbbell, and that allows us to curl it up to in the upwards phase. Okay, so the force generated is sufficient to overcome the resistance. Okay, another example would be the quadriceps muscle in the upward phase of a squat. Okay, so we could also put, and I'll go into this more in my movement analysis video, but there's also a concentric phase of movement, and that's when you're looking to go against gravity, you're looking to overcome gravity, then upward phase, and there will be concentric contractions. Okay, so this is the most common muscular contraction, and because it's the most common, this is why we often get the confusion of which muscle is the agonist, because sometimes we always think that the agonist has to shorten when it doesn't. We do have eccentric contractions, which we'll come on to, and that's why I wanted to mention the phase before my analysis video, because usually we have a concentric phase, and this helps us to not get confused, such as a weighted back squat when we push up and try to overcome gravity and the resistance, it's concentric, and when we're working with gravity, we're going eccentric because we need to try and resist it so we don't injure ourselves or face plant. So let's look at the eccentric contractions that I'm talking about. And as you can see, this is the downward phase of a bicep curl, and the clue should be in the name there. It's still a bicep curl. The agonist does not change here. The agonist that did the concentric traction on the way up and overcome gravity is going to continue to be the agonist and contract eccentrically to resist that gravity, injuring our elbow joint. So in eccentric contraction, the muscle lengthens as it contracts. Okay, so if we were to just focus on the last three statements, in isometric contraction, the muscle length remains the same as it contracts. And I'm not actually sure if that was on the slide there, but this is why we make videos. As it contracts is a key part to get a second mark in an exam question, okay? In concentric contraction, the muscle shortens as it contracts, and in eccentric contraction, the muscle lengthens as it contracts. Okay, so that's the difference between them. And the biceps brachii in the downward phase of a curl. So often people think, right, flexion of the elbow in the upward phase, easy, biceps brachii. Downward phase, extension of the elbow, well, that's the triceps brachii. But we're going with the gravity and we need to resist it. So the biceps brachii that was responsible for the concentric goes with the eccentric on the way down. So the muscle lengthens. Okay? And our statement here would be the force generated is insufficient to overcome the external load. So it just means that we're starting to lower that external load of the dumbbell rather than curling it up. As we curl it, we're overcoming the resistance and we're sufficient. And now we need to lower it. Okay? So I want to add this point here now. Again, more we'll go over it in the movement analysis video, but an eccentric contraction is associated with decelerating a body part or object or lowering the load gently rather than letting it drop. And I've kind of already explained that. The gravity is with us, so we need to try and resist it as we're going down to not get injured. So eccentric contractions, also known as negatives in the gym, and often burn the muscles a lot and will create that DOMS and the muscle soreness. Okay, they are generally quite harder to do. A bit like if you've ever hiked, people look forward to getting to the top, but as you're going down, Okay, you realize your legs are working just as much, okay, because there's a lot of deceleration going on with muscles lengthening. Okay, now isokinetic. So this is the fourth we need to know, and this is rare in the body. Okay, and isokinetic contractions, the muscle contraction velocity remains constant while force is allowed to vary. So I'll try my best to explain that in a moment with an example. But I saw this asked in one exam question, and it was the difference between isokinetic and isometric, and it's the only question I've seen with isokinetic involved, and the answer was accepted. The contraction speed remains the same. Okay, or remains constant. Sorry, remains constant. So the muscle contraction speed remains constant, and that's what isokinetic means. Okay, so the speed of the muscle contraction remains constant. So in the diagram now, I've put cycling on a stationary bike. Okay, and how we could get isokinetic contractions was if we were to be cycling at 50 RPM, okay, and we're trying to keep that RPM constant, right? Now you'll also notice on the bike buttons you can up the resistance, okay, level 2, level 3, level 4. Now if you were with a personal trainer and they said, I want you to keep a 50 RPM constant, okay, and you're on level 2. If they were to put you on level 3 and you still had to keep that 50 RPM constant, that would be an isokinetic contraction, okay? But usually these type of contractions are rare in the body, and they're really used in rehab centers in an experiment on isolated muscles, okay? So this is why we primarily focus on the other three, but we are required to know it. And it's muscle contraction speed remaining constant, okay? And I've tried to give you an example there, so I hope that's okay. Now the next two slides are influenced hugely from Mike Tyler's video, so I'm going to link that in the description, and they're pretty much just copies of that. But we needed to mention isokinetic in our video, which is otherwise I would have linked straight to that. So just to summarize then, we have contraction types. Isometric, no change in length. Example, static holds, such as the gymnastic rings. Isotonic, which means we have a changing length, but how does the length change? Well, as we know, concentric, shortening. The muscle length shortens, such as in the bicep curl in the upward phase. And then eccentric, the muscle is lengthening, such as the bicep curls in the downward phase. And that leaves us with isokinetic, which is a constant muscular contraction speed, muscular contraction velocity, such as cycling on a stationary bike at a certain RPM. Okay, and just to finish up, what I wanted to do is I wanted to put this in here and link it back to our functions of muscles, the roles of muscles. And again, idea from Mike Tyler's video. So we got the agonist, and as we know, the agonist is the main cause of the movement. It provides the major force, okay? But the antagonist relaxes to allow movement of that agonist. The synergist will support the agonist as well as stabilize a little bit, but it's adding to the total force of the agonist to make the movement more efficient. Now, important to note here, okay, is that synergists also have antagonists. As we know, antagonistic pairs, muscles must be paired, so they also have antagonists, which is why them lines are linking. And the agonist and synergist will contract together, and as we should know from this video, to either contract isometrically, concentrically, or eccentrically. Okay, so isometrically, the origin and insertion don't move, the muscle length stays the same as it contracts. Concentrically, as we should know, from flexion of the elbow, for example, the origin and insertion move closer, and to do that, our muscle shortens, okay, decreasing the joint angle. And eccentrically, the origin and insertion move apart, and that is because the agonist, the prime mover, is lengthening, okay? So muscle contractions, the agonist doesn't always have to shorten, it can lengthen too, okay? But while all that is going on, we still have the fixators working, stabilizing the origin of the agonist, okay? So fixators always contracting isometrically. Now we're going to go straight into the bicep curl. So we have the biceps brachii, triceps brachii is the antagonist, brachialis is the synergist, concentric contraction, the upwards phase of the bicep curl. Then the rotator cuffs as the fixator, and isometric contraction, okay? All within that upwards phase of a bicep curl. So there's your video on muscular contractions, and I've tried to link it to the functions of muscles, and I've tried to give you a little bit of insight into a video that'll be coming next on movement analysis and how we work to overcome gravity and then resist the gravity a little bit when we're going in the same direction. Okay, thank you.